Well, good afternoon, everybody. I appreciate you coming by to take a quick look at Rapid Cut's 3D printing webinar. Just to get started, my name is Ryan Watts. I am the sales rep for the Pacific Northwest area. I also have a deep background in 3D printing, so whether it be technologies or projects, you can post your questions into the questions area, and we will answer those as we go along. This webinar is going to go over the 6 major categories of 3D printing that are relevant today, and we're going to get started first by looking at a general overview of the processes themselves. So as you can see here, we have multiple categories: SLA, multi-jet, clip, SLS, FDM, and metal laser sintering. And as you can see there, there's 2 major categories to define these 6 different services: prototyping and proto-functional. Now, by stating that one is more suited than the other doesn't necessarily mean that that is a absolute rule. You can definitely use metal laser sintering for a single prototype. It's just that the processes are going to lend themselves, and they were designed more for proto-functional with the metal laser sintering, the FDM, and the SLS, as where the prototyping side, the SLA, the multi-jet, and clip, they really excel in fine detail. So each project's going to have its own application. All can be used for any, but just as a general, this is a good guide to get started. So we're going to kick off today with stereolithography. Stereolithography currently has the largest build platform of any of the 3D printing processes, 59 by 30 by 22. That has over 20 different materials available, including clears and many materials to simulate popular production plastics. Typical lead time is also very quick at 1 to 3 days. Now, this process builds by curing a UV material, basically an epoxy form, at 4,000 layers in a stacked format. The tolerance for this process is going to be 7 thousandths for your first inch and 3 thousandths of an inch thereafter, and that's cumulative, starting at one side of the part and working towards the other. This process, however, is really benefits the user the most when utilized as a clear model, such as a translucent or tinted model. Think of a headlight. Transparent fluid study, where you want to see how different types of fluids are flowing through your part, or you want to do an engineering model study where you want to see how the mechanics are working inside your part. Another excellent application for SLA is going to be doing any type of custom show part where you're going to be finishing the part and painting it, something that goes into a case at a trade show, not something people are actually using. Next up on our list of categories here is the multi-jet printing process. And what's exciting about multi-jet printing is that it allows us to not only use multiple materials, as you can see here in the little boot, it can also do multicolors, if you look at the example of the architectural model there. The chamber size is 20 by 15 by 11, typically twice as fast as conventional multi-jet, polyjet platforms, and over 12 dozen colors to mix and match to create a variety of different tones. Build chamber size, 20 by 15 by 11. But the process, what it makes it unique is it builds in 16 micron build layers versus your typical 4 to 7 thousandths that you see on other machines. This gives it a very, very fine resolution when you're looking at the fine details of your parts. You can do very small features, probably better than any other process. As we mentioned before, multi-jet builds in color, creating beautiful models, show models. It reduces the lead time required for painting when you're putting together show models. Now, they're not going to look as good as a hand-finished painted part was, but from 5 to 10 feet away, excellent model to showcase what you're trying to present with your prototyping. As you can see here, there's a little penguin up top. There was a great story about this penguin. There was a research center, one of the colleges had come up with a way to make a prosthetic foot. That was the challenge, utilizing the multi-jet printing process, they were able to make the boot there you see in the middle of the screen, which had a hard base in elastomeric style rubber boot and even somewhat simulated Velcro strip, allowed the penguin to get back to life as a penguin and enjoy himself. So real neat little study there. I always like to give an example of the parts. Next up is a brand new process. This is called continuous liquid interface production, otherwise known as CLIP. What's going to be unique here with CLIP is that we are not building in a standard layer upon layer format. Instead, we're building in a three-dimensional space using DLP lasers. This makes it 100 times faster than a stereolithography part. To put that into terms, you could light very easily, once this process is matured, call it 4 o'clock in the afternoon, have a part shipped out the same day, FedEx, built, finished, etc. You know, with an SLA at best, we need to start at the beginning of the day to accomplish something like that. The average build for an SLA part is about 4 to 6 hours, 15 minutes for CLIP. And there's 12 different materials available, some very exciting urethanes. And so, as we mentioned before, this process builds with a 3D platform. So it requires much less finishing because it doesn't have those same stair-stepping serrations that you see on a lot of prototype parts. You're going to have ability to build parts in rigid and rubber materials, print in urethane plastics, and hold a build tolerance of 0.02 of an inch. The only downside of CLIP is this is a brand new technology, meaning that there's a long backlog for this currently and only a handful of machines available. So as this process matures, you're going to see the benefits of this. Currently, though, it's in a form of beta, and for the next 6 months, you know, there's going to be a high amount of interest in this process, so you're going to need to give it a little time for it to fully mature. But this is what we can look forward to in the near future. Up next is selective laser sintering. Now this is the beginning of what I call the proto-functional style parts. You see SLS utilized heavily in additive manufacturing programs in everything from aerospace to common consumer products. Now this chamber is currently the biggest one we have is 22 by 22 by 30. We're going to be building again in a 4,000ths build layers, and your tolerances are going to be consistent here with the other processes, 7,000ths for your first inch, 3,000ths thereafter. But what makes SLS different in the 3D printing world is its ability to stack and nest parts, as you can see here. Any other 3D platform, for the most part, can only build a single story house of parts, where the SLS, like an apartment, can pack more units into the same space by capitalizing on its Z height. And as you can see here in the pedal example, you're able to produce 2/3 more parts inside the same space of machine. This reduces your part cost as well. So it's highly set up to be applied for low volume production, additive manufacturing projects. Still an awesome example for prototyping, as it can still do things others can't. As you see in the top example here, there's a webbing structure. This is a remote control car. If you look towards the back, you can see a little differential. Up towards the front, a servo. So they made this entire structure in a single piece. This is again due to non-supports. You can create any kind of structure because the uncured material supports the cured material. Think of an archaeological dig where you brush away the dirt and expose the part. That's the same way that this process is built. So it allows you to build parts that have structures that would be otherwise basically impossible to build, and it allows you to stack parts, making it a major win in the additive manufacturing arena. Next up, you're going to see here is our fuse deposition modeling platforms. Awesome process developed by Stratasys. Allows us to have a part 36 by 36 by 24, 24 inches of Z height, meaning you can really build a very substantial part. And again, 12 material options, and those are going to range from ABS plastics, polycarbonates, nylons, and even some high temp materials. So this process in general is going to build at a 20 thousandths build layer. So where PolyJet excels at the fine features, FDM is not going to be able to capture those same type of features. However, in larger parts, we found in real world applications that FDM is the tightest tolerance of the group in what we call final parts. When compared to SLS on 12-inch parts, they were holding a tighter overall finish tolerance. However, it does remain at 7 thousandths for your first inch and 3 thousandths thereafter. Again, the big benefit here is you're dealing with real production materials. There's a couple of them of note that are unique to FDM only, and that would be your high temp applications. There's 3 different old temps ranging from 375 up to 425 degrees, and that's an F, making it the most usable in the high temp area of the 3D printing processes using plastic. And of course, those are going to be nylon based materials. Our final process that we'll look at today is the metal laser sintering. By far, in my opinion, the most exciting of the processes. The major reason for this is it's going to allow us to build parts in metals that we otherwise simply couldn't in the past. One of the best examples of that is the fuel nozzle that you'll see in the center of the screen. This was at one point over 16 different parts, fixtures, welding and setup, people, were involved in order to get these parts created. Now they're simply grown in a single piece. So excellent example of how to best utilize this type of technology. Also, you can build unique structures in prototyping that you otherwise couldn't. It's the example shown on the bottom of the screen in the black circle there. You can build parts that have very unique geometry, especially surface geometry. It does still require a support structure, as you see in the top picture here on the bottom side of this art. However, with some shapes, due to the fact that the parts are metal, we can get away without having any supports whatsoever. So this process is going to build in 20 micron layers. Fantastic, very, very tight layers. As you can see in the examples here, these are straight off the machine, and you can expect this finish that's really consistent with a die cast part. 2,000 tolerance for this process. Unlike the plastics, it holds a much, much tighter finished process. In 10 different materials available, different varieties of aluminum, Inconel, different steels, cobalt chromes, and titaniums. So very exciting process. Typically, you're going to want to keep this, though, to parts that you cannot machine or cannot cast. That's really the way it should be looked at. It's a specialty club in your golf bag. It's a specialty weapon in your arsenal. That's the way you should look at it. Pull it out for those projects where you're going to be under a 16 by 16 by 10 cube, where you hopefully are going to need a few of them, where we can make, say, 10 of them at a time. If you look at dental equipment, a lot of the little tips they make, the inserts for implants, those type of things. If you look at the example here of the fuel nozzle, where we can make a whole run of them at once. So the idea here is really low volume production of complex parts that you otherwise couldn't make. So definitely what I would call a specialty process. So with that, we are through the different processes. This is a handout that we can send if anyone likes it. It's going to basically give you a quick breakdown of the processes. You've got the machine size, tolerance, you got your plastics, your materials, I should say, and your type of applications. And so this gives you a nice opportunity to look at something, quickly deter what you're trying to, or quickly glean what you're trying to accomplish and pick a process. So with that being said, we have a questions board here. If anybody has any questions, we'd be happy to answer them for you. All right, I've got a question here regarding direct metal laser sintering. No, this is not a process where you can expect to get a part in a day or two. I know that's very exciting when you think about CNC machining and just-in-time manufacturing, those type of things. But DMLS requires a wire EDM process to remove the supports, and the supports themselves are metal. So at best, you're looking at 3 days for a lead time on that part. However, if you're looking at a complex, say 3-inch, 4-inch round part, it's very complex turbine shape, in that instance, we might be able to make the part much quicker than a CNC process. So it's really project dependent. So great question here just came in. Is our pricing competitive with other 3D printing companies? And I would like to think so. You know, our goal is to provide, you know, high quality parts at a fair price. So I wouldn't call us the low cost winner. I would just say that we're very consistent in what we do. We usually keep our pricing, from what I've seen, competitive with others out there. But you never know, you know, someone might have a machine open for the weekend. There's always those situations. But generally speaking, we are going to be pretty close. And, you know, as a general rule, there is a guideline to how to quote parts from the manufacturers that helps us as an industry keep things in line. You know, we're all buying the same materials, etc. So generally speaking, you should see consistent costs coming from different companies, including ours. Side note though, when you look at costs, sometimes there are variables. We have the option of running some of these machines at what you might call high resolution versus low resolution. Some of the materials are more expensive than others, and so some of those factors can distort a quote's view if you just look at them quickly. So if you do see price differences from us or anyone else, that is likely the culprit. Okay, yes, so we do get a fair amount of requests for using 3D print as master patterns. So an example of that could be an SLA master pattern to create a urethane tool from which you're going to make a series of parts short run. Another example would be an investment cast, where we would take an FDM. It's got a water soluble material available that we can build a part out of, and then slurry that part, and creating a mold. Then we pour hot water in, it melts out the FDM pattern, leaving the cavity that you can then cast metal into. So that would be an example of using these processes for patterns. Yes, fixtures. Got a good question here on fixtures. So yes, a lot of folks are using FDM, SLS primarily to create fixtures. DMLS could be used, but it's just not cost competitive. So in a lot of cases where you're going to have fixtures, I wouldn't necessarily use it for a welding fixture, but if you're doing assembly fixtures, especially large ones, where aluminum is going to be a hindrance due to the weight, then a FDM or SLS fixture is an excellent solution for those type of applications. Yes, we do offer more than 3D printing. This particular webinar is just highlighting those particular materials, but we have other options such as CNC in 3 to 5 days, sheet metal in 3 to 5 days, injection molding is a good way if you need, say, handful of parts, 15, 20 parts. It's going to probably be cheaper to get one of our rapid tools versus, making a run of quantity of SLA parts. So that's, again, going to be project specific. The more complex the part is, the more that it's going to lend itself to 3D printing for shorter runs. But if you're making a dog bowl, and you need 20 of them, injection molding is going to win. Give you a reference there. By the way, I've been known for my analogies. If you guys are laughing at me, that's perfectly okay. All right, folks. Well, I appreciate you guys coming out today. We're going to have a series of these webinars where we're going to talk about different things in the future. Next week, I believe we're focusing on our injection molding process. Appreciate it very much, your time. And if you need anything else, just go ahead and email us, sales@rapidcut.com, and we'll get back to you right away. Thanks so much, and we'll talk to you soon.